I'm getting 24 milliseconds.
Are you in the IETF network?
Yeah.
Yeah. But Facebook doesn't.
Facebook
so
doesn't.
Our Anycast mapping thing will send you to the IETF network. Where was the last meeting held?
Yeah.
No. Facing it.
It's important to be happy. Yeah. It's Tuesday. Who isn't happy?
We always forget to update.
How does the
Gotta be in the microphone.
base it on GIP? Isn't it shove it into BGP and hope for the
Speaking
best?
of which, our mic line is like way back there.
I never understood how that worked.
I'm not going to claim to either, but I've sat in
Before we get too started, does anybody want to volunteer to take some notes?
So it's weird to sing in the US unless there's
I feel like you've paid your dues.
Is it US Seattle? I guess you would know.
Figured I might as well ask now. It's a good way to focus everybody on their laptop.
Actually, from the IP address, you can get a bunch of details.
It's important. We can shout them down if we need to.
Yeah, it doesn't have to be super accurate notes, but indication of what happened. And we'll have the recording to check over.
All right, let's let folks finish trickling in, and then let's actually get started. We've got a pretty full agenda today.
Put it against the wall. Oh, nice.
I have to say, your insights funny. My phone says here
now. Trace routing? Well, no. On the Google backbone, you got to go the other way. No, like there's a line between India.
All right, let's get started.
So if you try to go from one to the other, it goes the entire other way around. I don't know why.
David, we'd like to invite you to join the happy party we're having up here. Thank you for volunteering. All right, welcome to the very first meeting of the Happy Working Group. We hope you brought the appropriate attitude. I like it. Don't forget to go and join in MeetEcho if you haven't already. There's some QR codes scattered around. There's far more of you in this room than there are in there, so you'll need that to be able to speak at the mic. This session is being recorded. You can do this on your phone or on your machine, but you enter the queue by pressing the hand button, and you can leave it by pressing the same button slightly modified. And then if you're remote, you can send audio and video with the appropriate icons. This is the note well. These are the terms under which we participate here in the IETF, especially if you haven't read it yet this week. Now is a great time to do so. Please make sure that you've read it and understand it, and please ask questions if there's anything you don't understand. Take extra care to note the requirements around disclosing IPR that you may be aware of. We also operate under a code of conduct. Please be respectful and kind to each other, and you can contact the chairs, ADs, or Ombuds team if there are any concerns. We've got a couple of links here which may be slightly more helpful given that this is the first time you're going to any of these places. But we've got a working group materials repo on GitHub, which is where agendas and notes and all that kind of thing get staged, and you can send pull requests if you want to just change stuff, and then we mirror those into the data tracker. There is now a place in Zulip to chat about happy things, so that's very nice. And Tim over there on the screen and I, Eric, are your chairs for this group. We've got a fairly full agenda this session, so we're going to do a little bit of housekeeping, and then we'll walk through a couple of chair slides just to get some of the initial working group bring up stuff out of the way, and then we'll dive right into some fun topics. Before we go too far with that, who would like to volunteer to take some notes? Thank you very much. That's one way to do it, David.
Sorry, who was that, Derek, that's taking notes?
Yes. All right. We're going to spend a little bit of time talking about the charter. I put a QR code up on the screen in case you want to like read it and not be presented with a huge wall of text on the slides. I did not put the entire charter on the slides because that seemed like it would be painful. So we're going to go through some of the most interesting pieces of the charter here just to kind of focus what we're going to spend the rest of the session working on. But if you want to read the whole thing, that QR code should hopefully take you there. So I'm not going to read this all out to you, but essentially the gist of the next couple of slides are our main focus here, which is updating the core Happy Eyeballs algorithm, which we've been so far calling Happy Eyeballs version 3, that coming after 2. And this is going to incorporate changes that account for a whole bunch of new developments that have happened since 2. We've noted there's a couple of things here around having different tunable input values, and we'll talk about that. We're going to want to talk about how do we gather data to figure out what should different defaults be for that kind of thing. We've also tried to scope this work down to saying that this is going to be for establishing a connection. This is not, I have 5 different attachments, I've got Ethernet and Wi-Fi and everything else, and I want to figure out how to race across those. This is not how I'm dealing with my connection pool. So this is fairly true to the original spirit of where Happy Eyeballs started. And updating to take into account some of those later things. We've also got a section, and we're going to have to be fairly disciplined in how we discuss these and separate these to make sure that we use our time wisely, to talk about the impact of Happy Eyeballs on how we potentially mask misconfigured networks by making them continue to work and therefore nobody notices. We've got a talk coming later in the session with some ideas on kind of how do we approach that problem of reporting issues? How do we do that in a private manner? All of that kind of thing. So there's a whole section in here where we're going to spend a bunch of time talking about that. And summing all of that up, we end up with 2 core things that we're looking to deliver here. So we have Happy Eyeballs version 3, and then we have an informational document about doing some of that, detecting broken things and reporting those errors and all that kind of stuff. Does that all make sense? Sweet general nods of pleasant assent. All right, one quick administrative task we need to get out of the way since we haven't actually had a working group to do this in before, which is, as with many working groups these days, we'd like to propose using GitHub with the same contribution model that we've been doing pretty much everywhere else. So this is where, you have a thing you'd like to change or a problem that needs to be solved. You can file an issue. You can send an email to the list and somebody will file an issue for you and send you a link to it. And then as we come up with solutions to those problems, we send pull requests and we can debate exact wording in text and bike shed names of things. And then at the end of that, we cut a new draft version and publish those. We're continuing with the classification of some issues as editorial, some of them as design changes, and notably, as we start things off here, we're saying that we would like editors to have the freedom to merge both editorial and design changes under the chair's oversight until we get closer to last call. We've been doing this in a number of working groups so far. It matches a bunch of the docs that folks have written up about how to use GitHub. It tends to go pretty smoothly. If there's ever a, hey, somebody merged this and I had a bunch of outstanding comments on it, send a note to the chairs and we say, hey, let's not do that. And then things get better. If that doesn't work out well, then we can adjust this to place a higher bar on design changes. But we'd like to start with this and then we can always revise as we see how it goes. Thoughts, feelings, questions, comments, does that generally sound good to everybody? I see a similar set of nods as before. Cool, some thumbs up in the air, nice. All right, with that out of the way, let's get into our fun and excitement. So first things first, we're gonna go through and talk about the Happy Eyeballs v3 document. And I think the goal here is to consider this as a candidate for adoption by the working group. So that means we've got Nidhi and Tommy presenting that. Whenever you're ready.
It's a happy looking 3. Okay. Okay, so hi everyone, my name is Nidhi. I work at Google, and along with Tommy and my other co-authors, I'll be presenting the Happy Eyeballs V3 document. So just to briefly go over what we'll be talking about, I'll start by talking about the motivation and goals for the document, and then I'll move on to a brief overview of the algorithm, and then Tommy will go into some of the open issues and topics we'd like to make some progress on, and end with where we should take this document. So why do we need a new version of the Happy Eyeballs algorithm? We've had 2 previous versions of the Happy Eyeballs algorithm, the first of which focused on dual stack network hosts where v6 or v4 may be broken and how we fall back in those scenarios. And then the second one was a more sophisticated algorithm which incorporated host names that resolved to multiple endpoints. And since then, we've had a lot of changes in the DNS and transport area, including quick standardization and more use of that in recent years, more IPv6 only networks and mechanisms, SVCB HPS records, which give us address hints, priorities, ALPN, and encrypted client hello. So there's 2 main goals of our document. The first of which is to incorporate and take advantage of these new technologies since the Happy Eyeballs v2 document into a new version of the algorithm. And the second is to review and update the configurable knobs that we have in the algorithm based on data that we collect in deployed modern networks. So there's a bunch of text in the charter, but talking about what's in scope for this document specifically, that's the client algorithm for connection establishment that starts with a host name and then racing the different endpoints and then ending up with a single established connection to an endpoint. We've also had previous discussion about detecting and reporting misconfigured and broken networks in this area, but I believe there's a talk by Akamai later on, and so we'll discuss this and we'll tackle this in a separate document. And then specific mechanisms for scenarios with multiple network links and connection pooling is also out of scope for this particular document. So this is just a brief overview of the algorithm as it is specified in the current document. So we start with the asynchronous DNS queries, and as you'll notice, I've bolded the updated parts of this version of the algorithm. The main difference here is that we now query SVCB alongside Quad A and A records and prioritize that as they give useful hints for ALPN, ECH, the sort, and there's other additional considerations of how we incorporate that for querying, such as like waiting for SVCB alongside Quad A, where we previously only waited for Quad A.
Hey, Nidhi, Lars Eggert, Mozilla. I apologize for not having read the draft. I should really have done that, and it's terrible that I didn't. Is the draft intending to say anything about DOE in respect to not DOE DNS? Like, would you prefer it if you knew it was there, or do you not care, or do you do all of the DOE and non-DOE ones? Oh, sorry. Maybe I should have asked this a slide earlier. So how do you get the DNS results is I guess what I'm asking. So is anything DNS related? It's like which resolver do I pick if I have multiple options in scope of this?
Yes, it is. So Tommy, probably Apple. There is discussion that existed in V2 around how you select which resolver, and like if you're having problems with one resolver, what do you fail over to? It doesn't talk about encrypted DNS selection, but I think you should talk about like the different options you have. There are also some things, particularly when you get into like v6 only networks or v6 mostly networks, where you have to have very special considerations if you're using an encrypted resolver, particularly one that's not provided by the network, that doesn't have the DNSX4, and how you account for that correctly. So I think it has a little bit of a mention, but I think this is an area where we should expand the treatment to say, how do you correctly incorporate non-default resolvers?
So next we have the sorting of the addresses, which we'll use to erase the connection attempts. The main difference here is that we incorporate ECH keys, SVCB priorities, and the preferred protocols if they're present. You'll notice a little discuss there. This is something that Tommy will bring up in his slides later on, so we can go more in detail then. And then we have the racing of the actual connection attempts. The main difference here is that we incorporate quick now. Previously, we only raced until the end of the TCP handshake, but that meant that we didn't account for when TLS was broken or slow. And so we might have ended up with a successful connection, but it wasn't actually useful. And so now we race through the full handshake, including TLS or quick. And then we have the configurable knobs in the algorithm. These are different values that will have recommendations based on the deployment experience.
I see a Lars in the queue.
Lars Eggert, Mozilla again. I'm sorry, I should have said closer to the microphone. This is again on the last slide that you had. Yeah, I know. I didn't expect to be quite so active. I thought mostly I was listening, but I guess I'm not. So it's a model here that you are going to wait. So if you make DNS requests for quad A and let's say HTTPS, right, is the intent that you wait for all of those responses to come in before you start racing? No. So you basically, as soon as you get a reply, you start racing. Well, okay, so
it's a little bit more complex.
It depends on which way.
So there's an algorithm. It's in the draft. Yeah. Well, might I suggest you read it? So in Happy Eyeballs v2, the idea was if you get the quad A record, you start that right away. If you get the A record, you go, oh, let me hold off a little bit. And so there's, yes, I think you had that there.
Sorry, I'm not in the queue because I was doing other things and I didn't expect to get up again. So the condition that you've added on the quad A thing means that there's a gap in the sense that if you have requested service B records, then you should probably act on those immediately and not the A's and quad A's.
Yeah, that's right.
So it doesn't say that. It says it queries them first, and then it doesn't say anything about acting on it on
I think
service
there
B.
is text about that in the document.
Act on quad A if service Bs are not requested.
It doesn't say anything about acting on the service Bs, right?
Well, it's in the draft.
Right. Just to explain, the intention and what is described in the draft is that you kick off your queries. Originally, in the pre-SVCB draft, once you got V6, you go. If you got V4 first, you wait a little bit for V6. Now, if you get V6 either from Quad A or from IPv6 hints from SVCB, you go. Otherwise, you would wait a little bit for the SVCB to come back if that is required to make decisions like ECH, etc. But this is one of the things that I think we want to go into detail on in 2.
Lorenzo, I take it you have considered that in the presence of other implementations that don't ask for service B, the cache will be like colder for those records, right? And so generally speaking, the text here is probably oversimplified compared to the no doubt very flowery algorithm in the draft, but like you might have to consider that, right? Because if you start with the quad A and the service B will be basically arrive like 20 milliseconds later because it'll be a round trip from the authoritative. Yeah, but like the data will change as the client mix changes and your other clients implement the same behavior or similar, right?
So going back to the configurable knobs in the algorithm. So we have the resolution delay, which is the time to wait for the SVCB and quad A response after receiving the A response. And then we have the preferred protocol combination count. This is the number of the combination of preferred address family and protocol to be attempted before attempting the next combination. So for example, if we preferred quick and B6, we might try 2 of those attempts before we do a quick V4, for example. And then we have the connection attempt delay. So normally we would use historical RTT data to stagger the connection attempts, but in the absence of that, this is like the default value we would use to wait between connection attempts. And then we have the last resort local synthesis delay. This is the time to wait after starting the last V6 attempt before sending the A query. And there might be more knobs that we want to specify as we continue the discussion, but yeah, we'd like your inputs on that. And I'll hand the mic off to Tommy.
Okay. All right. So I'll go through a couple of the open issues. So we do have the GitHub. It has various issues that people have opened over the past year. Some of them we wanted to wait until we actually have a working group to discuss them in to try to figure out what people think is right. I don't think we're going to try to resolve all of these today. I just want to introduce them, get a bit of an initial sense. Hopefully at the end of this, the goal is to say, is this the type of starting point document that we would want to adopt for the main algorithm? These are tastes of the issues that we need to work on. Some of them may be simple to resolve. Some of them we may want to have interims or design teams or something like that to go into.
One of the things that we are looking for as feedback, in addition to thoughts on the issues themselves, is, hey, this is thorny enough. I think it would deserve some dedicated time at something like a virtual interim or a design team or something like that. So those are also great things to say at the mic.
Exactly. Okay. So you can look at the issues list. I'm kind of grouping them here into broad categories. So many of the issues are related to these nuances and the impacts of integrating SVCB. There are here, some of the overall impacts. It requires sending the new queries. That's relatively straightforward of how you send them out. You send them in the initial flight along with the A and quad A queries. You may need to send additional A and quad A queries based on what you've learned from the SVCB answers, but it's pretty straightforward, and that's really something that's already in the main SVCB RFC, and this is just including the description of what the client does. We have to include V4 and V6 hints that we get back. Generally, this is just improving the efficiency and performance. There are going to be some nuances about what you do when you get back the actual A and quad A answers too, and how you incorporate things. But I think this is also relatively straightforward. The thornier bits are how we deal with the sorting now when we have priorities and other considerations from SVCB. Other DNS record types like SRV also have priority, and so there's some analogies here, but this is, I think, where a lot of it comes in. Also, when the client may have preferences for particular ALPNs and any local policies around ECH or like security implications that come from the DNS records. Okay, yeah. So these are the tricky ones. They impact that sorting step, which is like the middle step of the algorithm. That's where I think a lot of the juicy bits are. Okay. So here is roughly the flow in like order of sorting that we have in the Happy Eyeballs V2 algorithm. So essentially the first phase, once you've gathered up all of your addresses, and the gathering step can happen multiple times. You can get more records coming in. But once you've gathered them, you do RFC 6724 destination address sorting. Then you look at any historical performance data or expected data based on the routes you know about. And then you do this last step of preferred address family reordering, which is like move V6 to the top, like do 2 V6 and then 1 V4, and then sort the rest out. That is what Happy Eyeballs V2 did. Lorenzo.
Given that you are explaining this,
Yeah.
one could you say, as you continue to explain, what you do when sort of you receive additional addresses, like should be, but like behind you in the sort and like things like that? Because 6724 assumes you get all the addresses and then you sort them. But here, as soon as you get one, you can start a sort, and you sort one, and you can't move it. You only have one, and then you get another one, and then maybe you can explain what to do then. Now,
Yeah.
HEV2 probably already did this, but as you're giving us this refresher.
Yes. So Happy Eyeballs V2 did that. Essentially, you do this whole sorting and gathering, and then you start connecting. And the connecting itself is staggered. So if other addresses, yes, sorry.
I got stuck on saying you did the whole gathering, but you didn't. You only got one address first,
Sorry.
right?
Well, not one address. I mean, like let's say I issue A in Quad A.
Sure.
Quad A can come back with 4 Quad A records.
Right.
If A came back first, I'm going to wait for Quad A. But yeah, let's say I got like a set of V6 addresses back. Then later I got some V4.
Right.
Then
you'll gather them later and you sort them again.
So essentially, you take. You gather everything you have at the moment, you sort it, and then let's say more comes in. What you would do is like the connection attempts that you've already started can stay outstanding, but anything that you haven't started yet, you throw that away and you put in the rest of the addresses in the order that you would now sort them in. Right.
You sort the new stuff after what you're doing.
You sort, yeah, exactly.
Well, the new stuff and the old stuff that you haven't acted yet, you put that in a bag and you sort it.
Exactly right.
Yeah, Kulevin. I have a quick question on this historical performance data.
Yes.
So you keep this as long as the interface is up, or did you change anything there? Is there anything additional we should consider?
There's nothing currently that we've changed there. So this is essentially if you have any historical data about the route or the interface as specific as you can, you use it. And this data generally would only stay for your particular network association on that particular route.
And I guess in a normal situation, your network goes up and down often enough that this is not like days or weeks, or
usually not. Yeah.
But is there something we should consider more explicitly? Because also, I mean, like I think the assumption that like when IPv6 is broken, it's broken generally. Yeah. That was true years ago, but I'm not sure that's true now anymore. It could also just be broken because there's just something on the path right now.
Right, that could be. I think that's good. You know, generally, when we talked about historical information previously, the details for how you store that were a little bit ambiguous because it's going to be really platform specific. So we can maybe give recommendations like it'd be cool if you could remember this and correctly identify that you're back on the same network or the same network path you were before, but that could be tricky.
So to go ahead.
I was rather thinking maybe you should remember it less long or should try again.
Sure. Yeah. No, yeah, I agree. It should be not very long.
Yeah. And just in terms of implementation detail, like in some kernels that's done like as part of the routing table. So if anything changes, it gets tossed out. But also like, remember this historical data, it's, I forget which, I think it's between 5 and 6 in RFC 6724. So 6724 has a bunch of rules that you sort, and it's somewhere in the middle. And if there's anything, it's pretty far down the list. And so this really doesn't matter that much because in most cases, like you get a pile of addresses and which one you pick doesn't matter. The DNS wouldn't have given you those 2 addresses if it didn't think that they were absolutely equivalent. So if you're adding this data, even if this data is wrong, it doesn't matter. Your wrong is not much worse than a random guess. So it's still
Although
worth
I think
not
the
throwing it out. Don't
big-
get me wrong, but it just
Right.
doesn't really matter.
The
too
big
much.
case is if you have historically remembered that V6 on this network was really slow or screwed up.
No, but that rule is below the
That's
V4
true,
and
that's true, that's true.
V4 and V6.
Lars?
Lars like Mozilla, I had enough time to come here this time because they were arguing. So so if we want to say something about this middle orange box, historical performance sorting, we should actually say something about it. Like, here's how you do it correctly. Because if you do it incorrectly, it has performance impacts, right? And maybe they are not small, but then maybe we don't need, maybe they're not big, but maybe then we don't need that step. But if we believe we want that step, we should like better define it in a way that people don't do it like terribly.
Yeah.
Right. So either if we have the box, we should say something about it, or we take it out.
Lorenzo, that just the arrow means that destination, like 6724 is done first.
Yeah.
Okay, so 6724 will resort on, like, is the thing that ensures that if you don't have V6, you won't try it. If you put the green box after that, then you'll put V6 at the beginning, even if you don't have a V6 address. So maybe.
Do you mean if you don't have a route?
Yeah, so the first rule of 6724 is avoid unreachable addresses, right? And so.
Correct. Those wouldn't even be in here.
No, I think the arrows are kind of misleading here.
Sorry. Yeah.
This is like the blue and orange happen as just you do 6724, but as part of that, like any address that you don't have a route to goes in the trash. So we don't consider them at all.
Right. It wouldn't even be in the list.
Leave them in the list. It
Oh.
won't delete them. It will leave them there.
Okay, this, yeah, I think we have something. And then the reordering, there was something back from Happy Eyeballs V2, this isn't new, where you would grab some like a V4 and put it kind of in position 2 or 3. So that's, we already made some override, but we're talking about Happy Eyeballs V2 back, you know, in 2015 or something.
Exactly. Okay. So what we have currently in the document for V3 talks about where you do the SVCB priority sorting, and then also if you have like, if you learn from that particular addresses are associated with particular ALPNs and the other ones, like, and they're not consistent across the different services, and it's like, how do you put that in the order? Like, where do you do that in the algorithm? This is what it currently says. I'm not sure about these being the perfect spots for them, and so I think that's one of the tricky things to work out. So we have the SVCP priority, and particularly it's interesting because like you have things like ECH or ALPN, and there may be multiple services that have different ALPN characteristics or different ECH characteristics, and it's possible that there is a higher priority service where the DNS configuration from the server is saying, I much prefer this set of addresses over these other ones, but the ones I prefer don't support Quick, they don't support ECH, and that could be very against what the client's preferences would be. This is something that I think Ben had added in this issue that he filed, where it's kind of up to the server to kind of give its priorities, and so the client should follow that. But I think this is a question to work out. I think we could take the server preference, such that like if the server like knew that for some reason the Quick server was like really not preferred or crappy for some reason, you could respect that and just hopefully recommend that people won't do that. All right, so.
Could the server do something silly like prefer this service, which is, let's say, V6 only or V4 only, and if you don't, fall back to the sub-service, which is V6 only or V4 only? They were the opposite, right?
Yeah.
And if it did that, then it that's not just a question of the client's preferences. It's even a question of like what it might have available to it, or like it just doesn't know. Like the server doesn't know where the client's going to be, and so the server operator might shoot themselves in the foot or do something otherwise suboptimal.
Right. I'm not too worried about the case where like I just don't have connectivity, right? Because like if you say, oh, prefer V4 at the top, and it's like I'm on a V6 only network, they're like, or vice versa, like that's pretty easy to just ignore. It's the case where like I do have dual stack connectivity, or I can do both, and you're telling me that your priority is inverted. And like,
what if one of them's broken, right? You only know that locally.
right. Okay, I don't know who's next in queue. Ben.
Hi. So yeah, server priorities are really important here. I can give you a few examples. First of all, for stuff that's actually broken, it doesn't matter. It'll just insta-fail. So you can respect the server's priorities while trying each one and insta-failing down until you find one that works. Secondly, I currently work at Meta. If you look at the HTTPS records for www.facebook.com, you'll see a priority 1 record and a priority 2 record. If you decide that you're going to use the priority 2 record for some reason instead of the priority 1 record, you're going to have a bad time, because we chose that priority 1 record to point you to your optimal server location, and we chose the priority 2 record to point you to a backup location in case the first one is dead, in case there's like a power outage or a fiber cut or something. So that's the logic of the service priority.
So
that's clear.
I want to, while you're here, to confirm, would you essentially recommend that the approach would be kind of within each service binding priority set, is that the algorithm runs within that of like sorting within the addresses you get back for that particular service, but then between services, they are discrete strata that don't get sorted and intermingled with each other?
I can't really think about this as an algorithm. I'm just sort of mentally not capable of this. I view this as a set of requirements. I just have no faith that we're actually going to pin down an algorithm that more than one party will ever implement. But we can lay out the requirements. And I think the requirement here is like, you have to try the higher priority thing first and give it some amount of time to succeed. You give it some reasonable chance of succeeding before you start trying the lower priority options.
Okay, Martin.
Yeah. So Martin Thompson, in my work in the W3C, we have this sort of priority of constituencies, and that sort of helps us establish how to set things like this. And I think the rule in this case should be the client's preferences win, right? And that means if you want ECH, you're going to go straight for the ones with ECH, no matter what the server says, right? If you want quick, you're going to go straight for the one that has quick, no matter what the server says about priorities or what have you. And sorry, servers, we want ECH, right? Yeah. And that's just it, right? If it's on offer, we're going to go for it. Second, I think servers fall into the second bucket. And that means service speed priority will definitely override address family considerations because they have an operational interest in being able to say that. If they really wanted to respect the fact that IPv6 is better than IPv4, if that's what the IETF says, then they'll put that in their priorities, or at least put them at equal priority. And when things are equal on those levels, then we can start talking about architectural purity and protocol choice. I think that's the reasoning that I would use in that case.
Right. Right. And then the conclusion from what you're saying there is that there's not a discrete priority between SVCB and the client side. Is that client preferences that impact security choices,
right?
Other, like, I think the quick versus TCP is an
quick
interesting
versus TCP
one.
Is an interesting one, but because the performance is likely to be that much better, we're going to go for it probably over just about anything else.
Right.
And there's kind of one more wrinkle in all of this is in terms of client preferences. One of the things that you will have is you will have a preference for going towards something that you know has worked in the past.
Yes. The historical affinity. Yes.
Unfortunately, I think that has to go below the server's preference. So if the server expresses a preference for something that works better, I think otherwise you end up in a situation where you can fixate on a very low priority one
Yes.
that has happened to work in the past,
Yes.
and the server really wants to kick you off onto something that's working better. And I think that in that case, the desire to pick one that's worked in the past, what has worked in the past is that you looked up service B records and A records and you connected to the server. And that's probably the thing that's most important.
Yeah. Okay, great. So, immediate discussion. Yeah, we talked about this. Boop, boop, boop. We touched on this a bit. ECH, I think, is the interesting one. The ECH SVCB document says that ECH should be consistent across all the services, so there should not be a case where you have to choose, but there may be. Exactly right, and like I think Happy Eyeballs and the client algorithm must account for the case where it is inconsistent, and it needs to make an opinionated choice there, either to follow what the ECH SVCB document says of saying the server gets to choose, or to say no, the client has the final say on its security and its privacy for this connection. So that will be a whole fun discussion to have. Off the topic of DNS, we have improvements that need to be made for v6 only networks and v6 mostly networks that weren't really fully considered. I think some of that's what we talked about, I alluded to earlier with like the DOE lookups, where we need to do an A lookup and do some synthesis. But there are questions like when we have a NAT64 on a v6 only network, should we recognize that an address is synthesized and treat it as less preferred than one that isn't synthesized? When we have to consider cases where you have DNS64 or Pref64 on the network, or DNS64 and Pref64. There was a recent issue in our own Happy Eyeballs stack that Jen helped point out and fix, where you can have a v6 only network that's using Pref64, does not have DNS64, and so you really better issue A queries, because you're not going to get synthesis otherwise. And that's something that needs to be recommended as we are doing the issuing of queries. And I'll do a quick shout out that at the hackathon, we got a great setup that Dave Klunka brought for doing testing of all these different configurations. And so that's a very useful thing when you're building a Happy Eyeball stack to verify with. Hey, Jen.
Jen Linkova, in V6 Ops, there is a draft currently, which we're presenting tomorrow, about let's slowly stop using DNS64. So you're currently saying you should try DNS64 in the absence of Pref64, and my suggestion would be actually say may, right? So because otherwise the goal is to eventually get rid of DNS64, right, and let clients synthesize locally. And so we're actually trying to send a message that DNS64 should be like slowly abandoned over time.
And I suspect that the consequence of this is that whenever we have Pref64, we just need to run the A and quad A query and just pretend as if the DNS64 didn't exist.
And actually, to add to that, in Happy Eyeballs v2, so the guidance at the time was we didn't have Pref64, it was DNS64. But sometimes there's a section on when sometimes that doesn't work. If you have an address that is kind of local, but you need to use DNS64. So in those cases, the draft had in those cases, do the synthesis locally. But I see that there's kind of a split. Happy Eyeballs is more about once you get results from the DNS, what do you do with them? How do you start your connections? Whereas the document in v6 Ops is how do you configure your DNS? And so in this case, I think that they're both totally aligned. So we're totally, and they're not stepping on each other's toes, because I totally agree with you. I think whatever we do here shouldn't get in the way of the local synthesis, but I think it'll slot nicely into this algorithm, because you can just say you won't get any v6 addresses, you'll just get the synthesized ones.
One thing that people have asked to carriers have asked to do is basically like run the quad A, and if you only if you and then maybe decide whether to run the A afterwards based on the quad A that you get. And that sort of they proposed it because they don't want to increase load on their networks. And I've had a hard time explaining to them that if clients did this, then it would provide a substantial disincentive to website operators to do v6, because if you're dual stack, the quad A that comes back is no longer synthesized, and you have to do the A afterwards. And so that sort of creates this like weird incentive. I think it might not matter if we do the A regardless after timeout, but that's something to consider. Like,
But I don't think we can just do timeout, because if you're on a non-DNS 6.4 network, but it has Pref 6.4, and you are talking to a server that does not have quad A, I mean, I guess, yeah, you issue it, but like now you're waiting extra time.
So basically,
I don't know
the question is,
wait.
If you do the A only after the quad A comes back, then you have this thing where like you can and you decide to optimize the case where the quad A comes back, and it's like, oh, like it's synthetic, so I don't have to do the A. Then that means if the server goes to dual stack, then you actually like it creates a latency penalty on the client. So I think, as long as you I think if you do the queries in sort of how the rest of the queries are, which is sort of staggered, I think it'll be fine. But
yeah,
anyway, just think about the incentive on the servers.
Yep. Good thing to dig into. Okay. Other topic we don't dig into now, but optimistic DNS is something that kind of slots into Happy Eyeballs, and I think it's something that is worth mentioning. I think there's a question of, is there something else that we should be referencing for that, or is it essentially being defined here formally? And that's it. So I think there's a question of, should we adopt this as the starting point? Do we want to have social breakouts? Do we want to just have like an interim meeting to go into like particular topics and like try to get all the right folks, like get the DNS folks in, get the v6 ops people in, and hash out some of the issues? We should also talk about data gathering and how we do measurement here.
Thank you.
Thank you. All right, we've got a couple of show of hands we want to do, because I think we want to get cracking on the adoption question. Then a little bit later, we'll talk about interims and hackathon and all of that. So now's a great time to go log into the Meet Echo if you've somehow not done that already. And Lorenzo, I see you rejoined the queue.
Sorry, because if you're talking about scoping now, I think one thing to point out is that if you're Chrome, or if you're Safari, if you're iOS, this is actually doable to implement. If you're sort of like, I don't know, OKHTTP, this is basically impossible. And so the question that I want to, because you don't control, like you don't have your own DNS resolver, it's like there's just a lot of stuff that you don't have, right? You don't. Go ahead.
You can implement this with getOutterInfo. What you do need to do is two separate calls to getOutterInfo, and you ideally need an asynchronous one, but you don't need your own DNS resolver.
Yeah. You're on two blocking queries on two threads. Okay, great. They'll do the queries in the same order, and they will block each other. But okay, you can do it. It won't do anything. But so. Okay, if you run it on Android, that's what it'll do. It'll block the second query because it doesn't like sending out two queries for the same thing. Like carriers especially don't like that.
What?
Yeah, if you ask for the same name in two separate queries, it'll block the second one until the first one comes back. Makes sense, right? Anyway, let me simplify to say, like, in certain networking stacks, it's very difficult to implement. So my question is for the scoping is, should it be in scope for this group to define sort of a lighter version, or should it not be? Maybe it shouldn't be, but that's sort of just a scoping question, right?
Or at the very least have some pieces of it that are, hey, this might be hard.
Right. I mean, for precedent in V2, it does account for like, if you can do this, do it this. If you can't do asynchronous DNS, here's kind of like the degenerate model of it. So, right. So I think many of these things are, if available, if you're on a dual stack network, if you can query SBCB, and I think they all have to have, it must have a way to handle what you do if you cannot do a particular piece of functionality. I think
Lorenzo, can we trouble you to make sure that there's an issue on GitHub for this?
Sure.
And it'll be under this doc for now, and if we decide to split it out somewhere else, then we'll move it around. But Lars, very briefly.
Yeah, Lars Mozilla. So the other question will be, is there anybody intending to implement Happy Apples version 3 within the limitations of getAtterInfo? Because if everybody is has their own resolver library, then we might as well not bother with specifying this really going to be very complicated minimal thing, right?
All right, let's take this to the issue because we do have a bunch of other stuff to get to. So.
As long as we then don't expect as a community that low effort networking libraries will do what it says in here, that's fine. Okay, then yeah,
understood. All right, Stuart, did you have a very brief comment to make while we all get logged into MeetEcho and check?
I will make this as quickly as I can.
Beautiful.
I'm not actually understanding the point that Lorenzo is making, and if it really is true, I think that's a bug you need to fix, because all of this work started back in 2008 at the Dublin IETF meeting, and it was because at the time at Apple we were trying to roll out V6 support, and we found there were a number of prominent websites that just had broken V6. If you sent them a quad A query, their DNS authoritative server would just drop it on the floor and not answer. So that caused these long 30-second timeouts when you went to these websites, you type in the domain name, and it would freeze for 30 seconds waiting for V6 to time out before it tried the A query. If today in 2025, Android has the same behavior, that if you do a quad A query, you fall into a black hole for 30 seconds where you can't do anything else until that's timed out and given up, that makes certain websites just unreachable. They're functionally unusable because the user's not going to wait 30 seconds. And I find it hard to believe that that's true, because we had to do this because we couldn't turn on V6 for Safari until we fixed it. It was an absolute showstopper. We couldn't ship without it.
There's a long answer there. We have lots of great topics to follow up on. On the adoption question, this is a slightly more serious poll. Have you actually read the draft? All right, looks like we're starting to stabilize here. Oh.
This document was replaced to add the name of the Happy Working Group.
I was amused to say prior from a 00, yes, but there are technically previous versions. And last question, do you think we should adopt this?
No, I think we should close the working.
That is entirely an option within our control, yes. Exactly.
My last tech
Yep.
Quick, someone grab his laptop.
Just on the planner, yeah,
I was going to say, sometime before tomorrow. All right, this is looking pretty conclusive. As always, we will confirm this on the list. So keep an eye out from email to the happy list. And it's a very nice happy list. And please chime in with your thoughts there, as well as having clicked yes here. All right, we're going to hop into our next presentations, and then at the end, we'll spend a teensy bit of time talking about interims and hackathon and all that kind of stuff. Next up, we have Kenichi. Speaking of implementers planning to implement, we have an implementation status update. All right, let me swap some slides over for you. There's that. And give me 1 second. Yes, wait 1 second. That should now work.
Okay. Hi, this is Kenichi from Google. I work for Chromium browser, specifically for network stack. Today, I want to provide a brief overview of the current behavior of the Chromium and the planned update for the Happy Hour V3 implementation. And let's start with the current behavior. The TLDR is that we only support Happy Eyeball V1 for TCP attempts. For historical reasons, we have separate code paths to attempt quick and TCPs. Yeah, and each code path performs its own DNS resolution separately. So these attempts don't share the DNS resolution results. And even though our DNS stack can query DNS quadray A and the HTTPS resource record asynchronously, these TCP and quick attempts wait for all DNS responses before starting connection attempts. And this is one of the major problems we want to resolve. After receiving the DNS responses, we sort received addresses based on the RFC 6724. Yeah. And for TCP attempts, we implement Happy Eyeball V1 equivalent, which means like we start using IPv6 address first, and after some delay, we raise connection attempt using IPv4 addresses. For quick, unfortunately, we don't implement Happy Eyeballs at all, which means like we only use the first address of the sorted addresses. Yeah, this is another issue we want to resolve. And here's this diagram illustrates how Chromium currently handles 2 HTTP requests and to try to make a connection attempts. So I don't intend to you to understand the details of this diagram, but I just wanted to provide a visual representation of what I just explained. And as you can see, we have a separate code path for quick and TCP attempts, and then each attempt performs its own DNS resolution. You may wonder why we have such an inefficient implementation. So this is mostly for historical reasons. Our code base is built on top of the TCP socket pools, which was designed before HTTP2. Initially, it wasn't intended to adjust a connection attempt based on the DNS resolutions. So that's why we have this kind of inefficient design. So we want to, so the current implementation hinders an efficient implementation of Happy Hour V3. So we are doing some rework on the connection attempt management logic. This refactoring involves a lot of changes other than the Happy Eyeballs, but for brevity, I focus on things that matters to Happy Eyeballs. There are 2 major changes. The first is to share DNS resolution for TCP and quick attempts. The second is to start connection attempt without waiting for all DNS responses. And this is a visual representation of the new code path. Again, I don't want you to take a closer look at it, but basically, so it's explains that we have a shared DNS resolution for quick and TCP attempt. and those TCP and quick attempts are managed by a single instance. And this diagram also includes the old SVC attempt, which I omitted in the previous diagram because it's too complex to include the auto SVC attempt for the old current previous diagram. While we aim to start a connection attempt as soon as possible, there are some constraints before starting the connection attempts. So first we wait HTTPS resource record before starting the TLS or quick handshake, because this is to support ECH. To prioritize quick, we delay TCP-based attempt unless the destination is known not to support quick.
Ian Sweat, Google. This is very pedantic, but I just want to clarify. We delay TCP once we know that quick is supported on that network interface, which is similar but very slightly different from the second bullet.
So could you say that again?
Okay. We race them until quick is known to work.
Yeah.
It's a subtle point.
I'm
being pedantic. I'm gonna sit down.
So I guess that sentences might be a bit misleading, because the intent of the sentence is that if the DNS resolution indicates that the destination doesn't support quick, and we don't know the auto SVC support from the HTTP server header or the other frames, so we don't delay TCP attempt. So, but this might be a bit misleading. And similarly, to prefer IPv6 over IPv4, we delay IPv4 attempts we prefer IPv6 before IPv4. This slide is, so there are much of overlap with the previous slide, but here's the naive approach we take to altering the protocol and the address families. So to prefer we prefer IPv6 over IPv4, and if an IPv6 attempt fails, we'll switch to the address family preference to IPv4, and vice versa if an IPv4 attempt fails. And to prioritize quick, we delay TCP-based attempts with some delays. The current code path is still under development, but we plan to start an early field experiment on Canary and Dev Challenge soon. So that's all I have. Thank you.
Thank you. Are there any questions, comments, clarifying questions? I see Ben Schwartz is in the queue.
Hi. So what's the status with this work of supporting non-default target names in HTTPS records?
So could you say non-default? Oh, okay, I got it. So unfortunately, we don't support non-default target names yet. We plan to support it after we implement the minimal version of the HappyIble v3. So we are currently doing some groundwork to support such kind of features, but we haven't implemented it yet.
Okay, thank you.
Okay, thank you very much for your talk. It's really appreciated that we have implementers that are talking about what they're doing. Been chatting with Eric, and I think what we'd like to do is add a wiki area to the GitHub so that we can put notes about implementations there. Also, I'm going to reach out to Dave Plonker and MapRG for tomorrow to have a slide in their intro asking for people that are doing any measurements related to this to forward them to the chairs, and we can include those on the wiki as well. And what we'll also ask Tommy to do is just to add a very minimal section in his draft, which obviously needs to be republished as IETF happy now. A very brief implementation section there that will just point to the wiki. So people reading the draft can find the implementation notes and any measurement information that we have. And then when that's published as an RFC, obviously the implementation section will be removed. So again, thank you very much for the talk. It's really welcome. Thank you. And any other implementers who are listening in, please do contact us and either contribute to the wiki or offer to speak perhaps in Madrid. Thank you.
Yeah, thank you. All right, next up we have a brief gear switch towards a very brief intro to some of the thoughts around error reporting and logging. And I believe Utkarsh and Nick are both here at some truly surprising time zone overlaps. So thank you both. And we'll put up your slides and hand you over control, and you can take us away.
Wonderful. Can everybody hear me right now okay?
Yes, we can.
Okay, wonderful. Thank you. All right, thank you for the opportunity, Eric and Tim and everybody else in the room there. My name is Nick Jansma. I'm here with Utkarsh Goel. We're both from Akamai. We've been working on this also with Eric Nygren, who I'm sure does a lot of IT stuff with y'all. Today, we wanted to talk about reporting of happy eyeball network errors through the browser APIs to origins to gain better observability and visibility into all the subtle challenges that can happen with happy eyeballs and related network errors. We did talk about this topic through the W3C's Web Performance Working Group back in September, October for TPAC last year. The reporting API that we want to surface some of this visibility through is owned in part by the Web Performance Working Group. But we wanted to bring the same topic here and continue the discussion and look for collaborators, etc. So I'm going to hand it over to Utkarsh to bring us through the first few slides.
All right, thanks, Nick. Can I have the next slide, please?
You should be able to hit the next arrow as of 2 seconds ago. Lovely.
Got it. Thank you. Hi, everyone. So I want to start with showing a text from the charter, which highlights some of the things that the working group is trying to address, and the detection of misconfigured deployments, recommendations on how to report issues, and similar things are something that basically drove us to come up with an idea, proposal, an initiative that would help improve how we are trying to detect issues on the network and see if there is something we can do to be better at monitoring the active issues or detecting and finding ways to improve our monitoring solutions. Okay, so I want to give an overview of the happy eyeballs and current browser behaviors, and obviously different browsers implement it differently. Happy eyeballs in overall has support for many protocols, and the way it typically works is that there are many different layers of protocols that go in different races to see which ones are faster in terms of connectivities, in terms of preferences decided by different browsers. And because a lot of this is happening in parallel, the browser APIs available through the network error logging and also made available by W3C, they only report the winning path. Basically, they tell us whether something absolutely succeeded or it failed. And there is really no notion of what really happened in between, what was tried, what was lost. And so here's really an example of how the DNS lookup phase and TCP connection phase really happens. So you could have a client that does a quad A lookup and then starts doing an IPv6 TCP handshake and gets a response. But in the same time, the same client could also be doing an A lookup. And because maybe the A lookup is slower than the quad A, the TCP handshake also gets delayed. And so And so if you were to look at the two races in parallel, V6 wins, and then the TCP handshake, the V4 is dropped. The fallback is basically that quad A happened. In a case where V6 takes too long, then IPv4 connection and A lookup is going to win. So like I said before, what we really don't know is what was tried, what failed. Was the quad A tried and timed out? Was there a problem? Was there a connection failure? Had we waited an extra few milliseconds, maybe the quad A lookup would have won. Same thing applies for an A lookup. IPv6 related problems. Was IPv6 tried, timed out? Was it really slower than V4? What really happened, right? And it's not so much that we are looking for the browsers to diagnose the problem for us and notify us. It's more about, did something work or not? If the browsers tried X, did X work or not? It's more about not having that information available to us to be better at finding problems out on the internet. So overall, if we are to look at the summary of network error logging on the left side, on the red side of the diagrams, you have everything we can see. That's the absolute failures. On the right side, you have, on the green box, you have the absolute successes, but everything in the middle is the fallback from happy eyeballs, and this is something we do not get to see. Post navigation, there's a bunch of stuff over there: TCP resets, H2, H3 stream resets, path empty related things. And this is again information that we do not see through the network error logging. So what's really happening for us is that happy eyeballs is helping the end users stay away from the network issues, but it's causing a lot of problems for server operators, network operators, where because the happy eyeball failure will simply just work, there are cases where we just cannot detect problems. And CDNs and server operators do lack some visibility into how all these network issues are seen, and that's also preventing us from proactively addressing them. ISPs sometimes also are not aware of how their new implementations or new configurations have broken certain protocols out there. And so, and we have also seen some real world examples from our internal data analysis where some set-top boxes were broken because of some IPv6 related issues. And some customers of Akamai, for example, they have been turning off V6 in areas where V6 just doesn't work, and it's really hard to diagnose what caused that to break. Okay, so at this point, I'm going to hand it back to Nick.
Yeah, thank you, Utkarsh. So what we have, there we go, thank you. What we have today is a browser API network error logging that reports other failures of the networking stack through the browser's reporting API. This is great for absolute failures, as Utkarsh was saying. It's not so good for cases where the network succeeded to the end user's point of view. You know, they had a successful navigation, but there were opportunities for improving it, right? As Utkarsh was saying, fixing the network a little bit, working with CDNs, working with ISPs, etc. We would like to try to surface some of these partial successes, partial failures, some of the places that we saw in that Venn diagram that we don't have any visibility today, to make the overall experience better for everybody. So we talked about this topic back at the W3C and the Web Performance Working Group a couple months ago. The concrete request here, the proposal here, would be to work through the IETF drafts to propose a better model for surfacing some of this data, adding dimensions, etc., some sort of logging, reporting within the specification, so that it can be handed off to the browser, if it so chooses, to surface the same sort of data through network error logging reporting APIs, etc. So looking for collaborators, co-authors, people that are interested in working on this stuff with us, and making progress in both, right? We have to work on some changes in the W3C and the Web Performance Working Group on the network error logging draft, as well as potential hooks into the IETF related stuff as well. I believe that is, let's see. Oh yeah, so there's another slide. There have been some discussions in GitHub on this in the past. You can look at these GitHub issues in the network error logging repo in the W3C. The slides do have a link to the past discussion at TBAC last year. Yeah. The last slide itself is just for visual purpose. How would we possibly surface some of this data through the browser? Well, the browser already sends reports on failures and successes. We could potentially surface some of these aspects of the navigation that were success, but we abandoned the quad A or whatever through the reporting API. So not trying to actually go into an actual proposal here, but just kind of a visual example of what we're talking about. That's all we had for today, and would love to see if there's any questions if we have any time.
Beautiful. Before we dive into the queue, I do want to say thank you for putting this together. And I think one of the things that is clear for us as a working group is that we're going to get to spend some time talking about, what are the exact requirements that we want out of this kind of solution? Where are those privacy bars? All that kind of thing. So with that said, Martin, you are up first.
Yeah. So Tim made this comment in the chat, and we've had a couple of discussions about network error logging and reporting and various other things. And probably the biggest concern here is that all of this detail gives you a great deal of information about the network topology around the client. Typically, when you're a server, the one thing that you get to know is that they connected to you and maybe what the reflexive address is to that particular client. And that's all you really learn. So you might learn that they're coming in over v6, but who knows whether or not there's some sort of intermediary in the path or what have you. Once you start revealing all of the things that are happening and succeeding or failing within someone's potentially private network, you have revealed a whole lot of information that perhaps a lot of people would prefer you not give out. And so I personally don't see a way that we can square that particular circle and make the information that you would need in order to do that sort of diagnostics without having that privacy drawback. Unless we get into some interesting questions of, can we use systems like DAP with differential privacy and all sorts of other wonderful things like that? And I just don't think it's worth the juice is not worth the squeeze on that one.
Yeah, and you bring up absolutely the same point that we also discussed in the W3C around this, and certainly the privacy concerns I think are top of mind. Absolutely.
All right, Tommy Pauly, Apple. So, metrics around happy eyeballs, certainly very useful. And there are metrics that we collect, and we've shared stuff at MapRG previously. We have information about what was the first option that was tried versus what was ultimately connected, how many options in between we have to fall back through. Very useful data for kind of understanding how stuff is working, where there's brokenness. That's all anonymized, aggregated data that's unrelated to any specific connections, though. So I think my main question for all of this, and I think this is what we're getting to with the privacy concerns also, is where are the metrics being reported? Is it to the server that you're connecting to like this? Is it to the network? Is it anonymously aggregated for something like DAP? And you could have it be done to report, you could get a heat map of what are the heavy hitters for broken host names. And that could be a way to do it. And then you eventually just kind of have a wall of shame that's publicly posted of lots of, it's a way to look up, is my thing being broken for a lot of clients? And then that's a way to learn and get that feedback loop. I think there are questions that we need to address of how real time do people expect this reporting to be, given that you have no reporting now, is it fine for it to be much delayed and aggregated? So I like the idea that I saw one of the slides here about documenting the dimensions of metrics that are interesting and useful around happy eyeballs. And that's something that we could do in an IETF draft that fits within the informational slot on the charter. As far as the mechanism for reporting, I think that's something that all the different implementations have more concerns about and maybe doesn't belong within the specific document. Maybe what we should do here is just document what are the different angles that are interesting to measure, and then we figure out how we report them separately.
Yeah.
Lars Eggert, Mozilla. So agree with the previous speakers. So originally, network error logging would give you some information about the one thing the browser tried and that failed, right? So sort of and that is sort of pretty limited and arguably okay in some certain cases. This, as Martin said, right, has a very different privacy profile. So I'm kind of wondering, as a straw man, like, what if we could limit this in similar ways? Could the server express what it thinks its preferred way of being contacted is? And if that didn't work, we would log an error. Right? So we wouldn't give you all the different things that we tried and that failed, but for your preferred way of that server being contacted, we would tell you when it failed. Similar to how we do it now for the one thing that didn't work. I said there's problems with this straw man, right? But I'm going to put it out as a thing that is much more limited than what you proposed, but maybe gets you something that would help you. Thank you.
Jordi Palet. I have been one of the persons that probably since longer time ago has been complaining about happy eyeballs. I am not saying happy eyeballs is wrong. I think it's good, but we should have implemented a reporting mechanism since day one. I have done deployments of IPv6 in more than 150 countries, and always we get a lot of problems because the lack of reporting. So definitively, I will be happy to contribute to this specific part of the job, or in general to happy. And I have some considerations. Some of them have been already mentioned before. The first one is we need to find a reporting protocol that is already implemented by hosting services or ISPs or bot, because otherwise it will be difficult to tell an ISP, hey, you have a way to get information about the broken things in your network, because they will not typically implement new reporting protocols. That's why in the previous 3 documents that I prepared about this, we were using syslog. Yes, there are some privacy considerations, but there are ways to anonymize the data and just say something is broken here, and we don't really need to tell which is the customer. Just in your network or this part of the network, there is something broken. The second point is I am not really sure who should receive the reporting information. Probably should be both sides, the ones hosting the server, but also the ISP, because in my opinion, most of the cases, the problem is in the ISP side. Of course, there are situations where it's the hosting server that, for example, they have broken IPv6 connectivity or no IPv6 connectivity at all, and they set up Quad8 records, which is quite stupid, right? So that's a very typical case. So don't know, maybe we need to report or to facilitate the reporting to both sides, and maybe the information that we provide to one or the other is different because the anonymity, privacy considerations, etc. Also, I think we need to understand that even if happy eyeballs typically it's going to be implemented in browsers, there may be other applications or even operating systems that can implement happy eyeballs already. So that may drive us a little bit about how we do the reporting. Thank you.
So Gary Fairhurst, simply saying thank you for the talk, because this is a talk, this is a discussion we have to have in this room. We have a milestone for figuring out how to tell the user what's going on, how to tell other people, and how to know if it works. So this was really good. even though we didn't get to a conclusion.
Thank you, Gori. All right, that was lovely. Thank you all. We're going to head into some of our wrap up here, but we will definitely be spending quite a bit more time talking about how we report different errors and brokenness. So we talked for a little bit earlier about potentially adopting the Poly Happy Eyeballs v3 document. You currently have an email sitting in your inbox that I would love for you to go respond to, similarly to the yes, no, and no opinion buttons that you pressed earlier. So now's a great time to do that if you haven't already. Let's talk very briefly about possibilities of doing an interim. Can we get a general sense of, would folks be interested in doing virtual interims for this? We've, I think, barely scraped the surface of a number of really interesting and potentially quite deep issues during this session. And I think having some structured time outside of a confines of a 90-minute or 2-hour IETF meeting might help us make some concrete progress on that. So far, we're currently thinking a virtual interim that tries to bridge a wide variety of time zones will be our great delight and happiness as chairs to try to schedule. These are the agenda items that seemed to come up during the conversation today. So I think the things that we're most interested in hearing right now are A, would an interim be interesting? Would folks be willing and able to attend? And B, what are the kind of hot topics related to this list that are missing from this list? David, I see you have started our queue.
Happy to help. David Skenazy. An interim seems a little bit premature here. I think that, like, as we have more, like, the adoption call will lead to more people reading the draft, looking at Lars, and that'll lead to more issues in GitHub, which is super helpful. And I think, like, we, speaking as an editor, can make a lot of progress on a bunch of these and kind of knock them out, provide information. I would say kind of for the ones where we get a little stuck, virtual interim would make sense. But like trying to reduce, calendar meeting time, maybe like wait a little bit before we go in that direction.
So yeah, we've been kind of going back and forth on this. I think the two main compelling arguments that we've heard so far are, one, that interims are a great opportunity for us to make some leaps ahead in progress that involve more than just a core set of editors talking to each other on GitHub. And so I think if you can make sure that we are getting the right participation, if everybody in this room can actually go and comment on GitHub asynchronously, then that is beautiful. And the other one is, if you look at this list, one of the unique things about this working group is we span a wide variety of topics and layers that are covered elsewhere in the IETF. And so some of the thinking was to invite folks from some of those other groups to come to said interim. We could alternately invite them to come to our GitHub and have a nice GitHub party with them. But thoughts on kind of what's feasible, what makes sense, how much are you willing to go drum up folks to actually go and do that would be great.
Yeah, and that's definitely workable. I just worry that we might do that and we get there and it's like, oh, this is an editor's meeting. Hi.
All right, I think I'm next. I think having one or more virtual interims would be quite nice. I think because I think there are issues like we were bringing up on the list earlier that have enough meat that I don't want to just be the editors working out, right? Because like we have this thing about ECH, SVCB, priority. How do we reconcile those? That's a discussion that I want to have time to unpack, and maybe we can have a proposal. But I think it's interesting to get actual consensus and working through those questions. What I would ask is that if we do have interims, they don't need to be long, but I think it would be good to have them, any particular meeting, be very singularly focused, because we have different topics and not everyone's going to be interested in all the same topics. And so like there could be one that just goes into like, what do we have to do for all the V6 ops related, V6 only, V6 mostly cases? And because things are hard to schedule, that can be tuned to make sure it's available to some folks who can make it. And then when we need to have the debate around how do the DNS records interact with ECH, that can be a separate topic where we can just spend 45 minutes or an hour just really digging into that one issue.
This is kind of a small interim / extra big design team meeting.
Lorenz, clearly, despite the earlier derision, I'm going to try again. There's a lot of networking code in the ecosystem that does not or cannot do this or does not do this right now. And I think those people aren't in this room, hence the reason for the derision, I think, possibly earlier. There's a lot of app code that doesn't use something that's way as sophisticated as this. That doesn't run on iOS, because on iOS you have to use the right stuff. But on other OSs, you can do whatever you want. And I might not like that, but that's what people do. And so getting those folks in whatever sort of virtual room, those folks don't go to IETF, but thinking, the Square folks that maintain OKHTTP, they might be interested, right? And I could try to put them in contact, because, whether they do want to do anything about that, I don't know, but at least having a constituency from apps that bring their own stack, like I said, just to give a point, 70% of code on Android uses OKHTTP, and OKHTTP can't do any of this. So those folks might be interested in coming. That's all.
Thank you. Yeah, and if you can help us make contact with those folks, and if other people know of interested parties that don't spend a lot of time in this room with us, that would be a wonderful place to pull them in. All right, Tommy, I see you rejoined the queue. Did you have another thought, or was that just a reflexive? All right, well, you're gone now. Ooh, fancy.
Yeah, so just oh, sorry, you've got another thing. Yeah, just before we move on to that, we're a couple of minutes over, but yeah, I think what we can do is, if these issues can get into the issue tracker, then we can see how they crystallize there. We might have violent agreement on many of those topics anyway, so not need to discuss them in detail. But let's see how we go from using GitHub, and then maybe in 3 or 4 weeks, see if there's value in an interim before Madrid or on a specific topic.
That sounds like a good plan. So especially for David back there, you have a task in the next several weeks to demonstrate that we can pull in some of the right folks to that conversation, and we'll see how we make progress there. And if we do, then that's great. And if we need kind of more face-to-face time to really hash things out, then we'll do that. Last but not least, we'd previously brainstormed a list of other groups that we should probably be pulling in to talk about some of this stuff. And we very often list these things in charters and make a passable effort closer to last call to run these some of our documents by those groups. I think this is a case where we need to be a little bit more proactive about seeking that input. So this is on the screen specifically for you to look at and go, oh crap, we forgot this other group that really should be involved, and I care deeply about that. So please do shoot an email to the chairs, or file an issue on GitHub, or stand up right now and shout, whatever makes you happy. Oh, that was not an accident. That brings us to the end of our agenda. So thank you for attending the Happy Working Group's first meeting.
Thank you, everyone.
Also, extra thank you to Vanessa for taking notes in what is a slightly crazy discussion to try to take notes for.
Yeah, thanks, Vanessa.
Oh yeah, this was quite chaotic. Thanks, Vanessa. I'm sorry. You're done. Do you have dinner plans? I do have dinner plans with my colleague.